Hello, fellow vertebrates. My name is Brian with a Y, as you know, and it's Friday, so that means it's time for another software demo. So, unfortunately, this time when I undertook to write this software in 2 weeks, it did not go nearly as well as I hoped it would. What I was trying to do, I was trying to make a kind of a game engine that would run in the terminal so that you could design games that could be played in the terminal, like Pong. That's what I wanted to do. I thought, surely Pong can't be that difficult. It's Pong. Way back in the day, Pong was actually written on hardware. There was no code involved in the first iteration of Pong. It was all circuits. Circuits did absolutely everything in that game. So I thought, surely it can't be that difficult. And I was very wrong, as about 4 hours in the STC today can testify. So what happened is, it turns out that I was using this module. It's called Termion. I'm sure it's around here somewhere. Yeah, there it is. Termion. I don't know how you're supposed to pronounce it. I call it Termion. It's like this low-level terminal module that lets you access terminal data and change terminal data and do all this kind of cool stuff. And that's exactly what I needed. Problem is that I can't figure out how to use it. And if there's a way to do what I'm trying to do, I do not know what that way is. And it is, there's documentation of a sort. It's saying things like, this is this function, it takes these parameters, and that's it. Doesn't say what the function does, doesn't have examples. There are a few examples on the GitHub, but not nearly enough for someone like myself. So I unfortunately could not figure out how to get input. There is a method by which I can get input, and I was messing around with it a little bit during those 4 hours, but I failed to bring that to fruition because using that system would require me to restructure my entire graphics library, and even then it might not work, and I'd have to do a lot of finagling, which I did not feel like doing because I was already very tired. So, to cut a long story to a short story, as they say, or in the Rust world perhaps, to cast a U64 to a U8, I did something else instead. Fortunately, I can still fulfill the goal that I set for myself. Just, it's not a game. I wanted it to be a game. It's not. It's more like, well, I better show you what it's like. To do that, I'll show you guys in this terminal right here. We will just write cargo run, because that is how you run Rust projects. And yeah, this is what I've been doing. There are all these little circles. This was supposed to be the ball in a game of Pong. So you have all these little circles and they bounce around. And this was essentially the functionality that I figured out on Thursday. I was like, okay, I have a ball object that bounces off the walls. This is pretty much what I need to do Pong. And while that's true, the other thing you need for a video game, very important that you need it, is you have to be able to interact with it. You have to do input, which I failed to do, unfortunately. So yeah, all these little ball things, they're bouncing around. It's really cool. They have randomly decided positions and randomly decided velocities at runtime. So it's always different. There's also a random number of them. Looks like there are a lot. They're all bouncing too fast for me to count them accurately. But I think you can have between 1 and 10 bouncing at one time. And it stopped. I had to implement a timer of some kind, because if not, then the only way to make it stop is to press Control-C. And if you press Control-C, then your cursor stays invisible. And although that's kind of cool, I would rather be able to see my cursor sometimes. Know what I mean? Yeah. So now that we've gotten the demo over with, let's continue on to a quick code explanation. So the crowning glory of this project, I would say, is the surface class, and that's in the surface module. So the surface class, what it is it's what this screen is. How it works is it's a vector of vectors, and those vectors have characters inside them, or chars as they are called when there's just one character. And so a vector of vectors, a vector is like a list. It's a list of values. And if you have a vector of vectors, then you have a two-dimensional vector, as it's called, and it's called a two-dimensional vector because you can think of that as like you have a list, and in the list you have all these other lists that are like, and so if you have a list of lists, then you have two dimensions that you can work with, and that's where this really comes into play. And so these all these functions that I have for the surface, what they do is they just treat this surface as a vector of vectors. And so you can draw a character to the surface. The way you do that, you say, this is where I want the character to be, and then the vector of vectors is like, okay, I can do that, and just goes over to where where the point is in one axis, and then it goes over to where it is in the other axis. Because it's a vector of vectors, well, it goes there through vectors. It goes to the right place in one vector and then goes to the right place in the other vector. And so, yeah, that's how it works. I did make a coordinate class just because I hated typing these little parentheses all over the place. Of course, the coordinate class required me to type quite a few parentheses, as you can no doubt see. But it was not too bad. And I really like having this definite x, y, so I don't get mixed up with what I'm putting all over the place. And I have this verify point, which is one of my brighter ideas, I feel. It allows you to check and make sure that the coordinate is actually on the surface, because if it's not on the surface, then you shouldn't be able to draw there. And if you try to draw there, then the computer will get mad. It will be like, hey, that point doesn't exist. I can't draw anything there. And so, obviously, you can't draw something, or you shouldn't be able to draw something if it isn't there. And so this function is there to help with that. And then display, this just goes through and prints each row of the surface onto the screen. And then write, this is the other really cool thing. I thought of it and I was like, man, that would be such a helpful tool, because this was back when I thought I was still going to be able to make an actual game here. And I thought this would be really helpful for stuff like the score or player names or whatever. And so I still did manage to find some uses for it. It was very helpful for debugging. How this works is I call it write. And what it does is you say, hey, remember that surface I told you about? Well, I want you to write a message onto that surface. It goes over by x coordinates, as you can see here, dest x plus I. It goes over that. It iterates through the string and uses this draw char function from earlier to draw to the surface. So that's really, really helpful that I have this draw char function, and it calls the verify point function. So like all these functions, they call each other and use each other to do all this really cool stuff. And because it's in Rust, it's really fast. And so now, yeah, I also made this drawing line function, which is pretty cool. It's where you give it an A and a B, and then it will draw a line from the A to the B. It does that by calculating the slope between the A and the B. I would like to be able to say that my recent calculus class has made that easier, but honestly it didn't, because it was just like a linear function. I'm not going to draw like sine waves between A and B, although that would be pretty cool. Maybe I should do that next time. We'll see about that. And then there's blit. Blit is, I don't know why it's called blit. Blit is just like a word that people in computer graphics apparently use. I read this somewhere, that it just means sticking one image onto another image. It's called blitting. So that's what I called it. And this is cool because it takes one surface and pastes it onto another surface at a specific location. And that is so useful. So if you had like a dragon or something that you were trying to make, and it had a big image that was a surface, and you'd drawn all these little dots for like wings or fire or whatever dragons have, then you don't have to go through and call, okay, so draw this one right here, draw the next pixel or character right there, the next character over there, and then when we get to the end, go back over there. Yeah, that would be really irritating, as you can no doubt tell, and so that's all contained in the blit function. And so you just call it once, and then it does all of it. And once again, because it is in Rust, it goes really fast, and it does not wait around. And then the screen class is what I actually use. It's very similar to the surface class. In fact, it is the surface class in a way. It owns one surface class. And the reason it's different is because the constructor, when I'm like, okay, make a new screen, I didn't want to have to think, okay, so how wide is the screen? How tall is the screen? How big is our terminal? I didn't want to think about that, and so I just encapsulated it into the constructor so that whenever I create a new screen, it's automatically the size of the terminal window. And all these other functions, they really just call the functions on the surface contained inside of it. So I can call them a little bit more directly, although display is different, because when I display the screen, I don't want to like draw the screen and then next time I draw it, go down here and draw the screen, the next time go down there. I don't want to do that. So instead, I move the cursor, which is where you write a letter, boop, and then it moves ahead, boop, boop. That's how writing works. You've all seen this in your favorite writing office software, that little line that you just type and it goes do 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 do. That's the cursor. So I move the cursor to 1 1 or 0 0, which is in the top left. It's going to be reversed for you. For me, it's over here. Top left coordinate of the terminal. And then when it writes things, then it just writes over the top of what's already there. And so that means I don't make the terminal get constantly bigger and bigger. You can't scroll up to see what was there on the last frame. And I do have clear here, which might be unnecessary since I should be rewriting all of it anyway, but just to play it safe, that is what I'm doing. And yeah, and then I go through my surface contents, and I just actually, I remember now, I was having a little bit of trouble with this because the printing wasn't fast enough. Like it would print to the screen, but it wasn't fast enough to keep up with Rust. Rust was just too fast. And so when things got near the bottom or the bottom right of the screen, then they would disappear because the computer wasn't fast enough it was going faster than itself in some respects. It couldn't draw the things before it had to draw something else there. And so I fixed this I should probably refactor this. I fixed this by having this, I have a current row, and so I just kind of copy from the row I copy from the surface, remember, which is a list of lists. I copy from the list into a row, a string, and then I paste that into the console all at once. And then I go on to the next row and I do that all at once. And so because the computer could print it faster, instead of having to print each individual character, it could do it row at a time, and because I figured out this this std out flush, I figured out that this is a thing you can do, which flush means update the display. So because I could tell it to update more often than it could keep up with itself, which was very helpful, doubtless to say. And then here in the game classes, somewhat unfortunately named because I thought I could have a game here, I have a paddle, which did work. I did a little bit of testing. The only problem was it couldn't move. I guess a possible branch for this project would be to design an AI that plays Pong against itself. Or not an AI, just a computer-controlled player, which is, I think, an algorithm, not an AI, not technically. And so, but I mean, that wouldn't be that interesting. I think the computer would be too good at it to lose ever, so I'd have to implement all this randomness and stuff like that. But it could be cool. So that is a definite option. And then I have the velocity, which I use to make moving points around easier so that the ball can be moved around more efficiently. And then the ball, it has the apply velocity, it has the draw, which uses the blit function, very helpful, and the new, which creates a new ball, and the bounce, which is I pass an X and a Y, and then it reverses the speed on the X or the Y, and the Y, sometimes depending on what you run into. And then I'd just like to quickly show off how it sizes dynamically. So I'm going to make my terminal really big, and then I'm going to cargo run. And as you can see, all the little objects are now bouncing off the terminal walls where they are now, not where they used to be. And that's because the size of the terminal, or the size of the screen object, is determined dynamically at runtime. And while that's running, I can even go over here to my VS Code terminal and run it in here. And it even bounces off this wider, shorter terminal. So yeah, all kinds of cool stuff you can do. Unfortunately, no input. I will probably be figuring that out one of these days and returning to this project because I have some ideas that I would really, really like to implement in this type of environment. I think that would be really cool. So yeah, that is it for this demo. Hope you enjoyed this video. Thanks for watching, and I will be back not in 2 weeks, but in 3 weeks. This next sprint is going to take 3 weeks because of Thanksgiving. So I'm thinking I might want to try something a little bit more ambitious because while I'm sitting there digesting, I almost said dissolving, which is technically correct, but somewhat unnerving. While I'm sitting there digesting my food after Thanksgiving, it would be really nice to work on some code. I'm going to have a couple of extra days, so I'm thinking I might want to try something a little bit more complicated. Then again, I thought this was going to be easy, and it turned out to be very difficult, so we will have to see what ends up happening. But thank you for watching.